All right, my name is Stuart Jones. I am a global product manager for the MACSQuant, including the MACSQuant 16. So thank you everybody that's joined. I look forward to sharing some of the kind of new highlights we have with the MACSQuant Analyzer 16. Again, colorful new possibilities in automated flow cytometry. So a quick look at the agenda. We'll kind of discuss the hardware and go through a device overview. We'll review some of the key software points and updates. We'll review service and support, go through some sort of performance data for the device, and then finish with a recap. Again, we will have the opportunity for some questions at the end of the presentation as well. So to start in with the device, we launched our first flow cytometers in the 2009-2008 timeframe with the MACSQuant Analyzer. This is a 3-laser 7-color device. This kind of grew into what we know as the MACSQuant Analyzer 10, which added an additional detector, giving you 10 parameter, 8-color flow cytometer with the MACSQuant 10. And then with 2011, we launched the MACSQuant Vibe Analyzer, which incorporated a 561 yellow laser. As of last year, we've expanded with the MACSQuant Analyzer X, our MACSQuant X, that brings high throughput screening capacities to the MACSQuant 10 Optical Bench. And now with the launch of the MACSQuant Analyzer 16, kind of rounded out the portfolio for higher parameter data acquisition. So we kind of coined this the Fantastic Four. So with the MACSQuant Analyzer 16, it's really about bringing simplicity for setup, acquisition, and maintenance. So a lot of the features that are inherently part of the MACSQuant Analyzer that come from the automation. So automated cell counting, automated labeling, sample processing, now the ability to easily do multi-instrument alignment. In addition to that, of course, it's about bringing more color to our instrument portfolio. So we've expanded from 8 colors up to 14 now with the addition of 6 channels. We have also added violet side scatter capability for small particle applications. To give you a look at an overview of the optical bench, the 3 lasers we offer, the 405, 488, and 640 red laser, and the array of different channels that are available off of each. Now, this is not an all-encompassing list of floors that can be run on the device, but just a small look at what you can run. And of course, you can match up floors based on the filter configuration that we offer here. Some of the key hardware features to look at when it comes to the laser excitation is the increase in power that we're offering. So the 405 is a 65 milliwatt laser, the 488 is a 50 milliwatt laser, and the 640 is 72. And essentially what this translates to on the detection side is by having more power in the laser line, we will, of course, increase the amount of light generated and hopefully the sensitivity on the back end as well. From the side scatter perspective, again, moving from a 488 to a 405 nanometer laser for side scatter helps us to further incorporate small particle detection. The event rate now capacity is up to 15,000 events per second with a minimal measurement volume as low as 1 microliter. The max measurement rate will allow you to acquire in 25 minutes 5 microliters per well from a 96 well plate, and we have increased the built-in monitor size on the device to make the interaction easier for the user. The carryover is conserved under a standard mode in normal operating conditions for 0.01%, which is really one of the lowest carryover devices in the market. And this instrument does incorporate the ability to do rare cell enrichment or rare event enrichment with the max column and max microbeads. The robotic needle arm is really the heart of the device, allowing for sample mixing and auto labeling. So when you kind of look at the robustness for having 3 spatially separated lasers and 16 optical parameters, robustness was a key thing we want to deliver with our fixed optical bench. From the automation standpoint, we bringing things like maintenance, startup, shutdown, and cleaning are all configured automated processes on the device. The ability to do sample labeling, calibration, and QC, automated counting, and of course sample processing from a 24 tube rack or 96 well plate format. And what this really comes out to in the end is reliability and simplicity. So lower demand for experience and lower demand for personnel to operate devices, but also to be in front of them while they are acquiring data. From a fluidic standpoint, the device incorporates a syringe-driven pump system. This, again, is what enables the volumetric counting that we've mentioned before. It also enables us to kind of act like a robotic pipette. So for sample mixing functions or auto-labeling functions, we are able to do that because of the design in this syringe-driven system. To get back to cell counting, this is on a per milliliter or per microliter basis for every population that's really acquired in your data. And its accuracies validated for 25 microliters or higher. And this is, of course, generated without counting beads. When you look at a dilution series, I think this is the most kind of impressive operating range, is that you can go from a really rare sample up to really concentrated sample over a large dynamic range and maintain really nice linear relationships of your count. And I think that's something that we don't see in a lot of other devices in the market and kind of head-to-head comparisons. This next slide was supposed to kind of show you through a video the process of calibration. What happens on the device is we have a bottle of calibration beads here. They're scanned by the instrument. Once they're scanned, it will pull up a template on the device's computer. It'll prompt you to add a drop of microbeads. The device will come out, dilute the calibration beads, mix them, and then take them for sample acquisition. So again, reiterating the steps, you're placing your tube in the single tube holder, scanning your calibration beads, dispensing the drop of particles, and then moving on to the touch screen to start the process, and that's it. Additionally, features that are available would be the automated sample labeling. So this gives you the ability to add reagents of really any liquid type. So something like a live dead dye, such as PI or 7-AAD, an antibody cocktail, and this is all time and titer programmable, meaning that you can dilute your sample as needed, and there is a wash station underneath this robotic needle arm that prevents carryover from sample to sample. And that's also what gives us such low carryover with cells as well, because of this wash station. So the device is coming out into the reagent vial. It's taking a reagent. It'll add it to any specified wells that you define. In this case, it's going to mix your sample. If there was an incubation step taking place, it would wait and come back after the incubation and acquire the data. So you have a lot of control over how you set up your applications and your assays with this auto-labeling function. Additional versatility that comes along with the auto-labeling is really the ability to process from almost any tube or plate type. So if you have, of course, fax tubes, 96 well plates in a deep well, U-bottom, V-bottom, flat bottom format, as long as it's fitting in a kind of standard 96 well plate array, it should fit on this device. These racks that we offer are called chill racks. We have a chill 5 and a chill 96 format, and they're called chill racks because they do maintain sample viability by keeping your cells cold during the acquisition, and that's simply done by placing these racks in the refrigerator at 4 degrees, and they'll freeze and kind of have a ice-like matrix inside to keep, again, samples cool during acquisition. We've recently released a we call universal reagent rack, and as you can see in the image here, it allows you to do auto-labeling from glass vials, which we traditionally offered, but also the kind of Sarstedt plastic vial format as well. One thing we offer for almost all the devices is seamless robotic integration. So we have design integration into robotics platforms from Thermo Fisher, from TCAN, from Hamilton, and Hi-Res. We also really have kind of an out-of-the-box solution with the Thermo Fisher Cytometry platform. So there's no kind of hardware drivers, anything that have to be prepared or scheduled. You can purchase this kind of as a package if you have high sample demand or need conditions for cooling and heating, etc., that cytomat device would enable those functionalities as well. So taking the next step in transition in the presentation, we'll focus on some of the new software tools that are available with the MACSQuant 16. And so we have a new technology we call Smart Gains. And what this allows us to do is really, from a universal setup to, we say, global cooperation standpoint, allows you to share instrument settings among devices or to keep a stable instrument setting over a long period of time. And this is really about bringing consistency to all of your assays into multi-instrument scenarios as well. And so this really translates to reliable data from test to test, from user to user, from instrument to instrument, and across sites. So we have a lot of companies and even academic groups that collaborate around the globe, and it's to be able to align instruments and do experiments in an aligned way is really, I think, a challenging process in the current environment. And one of the key points we wanted to focus on was making that easier for our users that have the MACSQuant platform. And so what this really comes down to is the reliability from kind of a universal standard. So the Lighthouse is really just to be an emblem in the presentation for what calibration beads can offer. And so with all of our calibration beads come encoded values of fluorescent brightness. And when you scan a calibration bead into your device, it's recognizing those values and it's able to provide that to the instrument so that it knows the correct mark from day to day, from lot to lot, etc. What this means from an instrument setting standpoint is that if, at the start of an experiment, if you're measuring your calibration bead, let's say at a gain of 400 with an MFI of 600, if there's any changes over time, again, that are encoded through these calibration beads, we can address that with this Smart Gain technology. So after each daily setup and QC run, MACSQuantify automatically adjusts your PMT gain to ensure consistent results. And MACSQuantify is the software that's operating the devices. The instruments are calibrated to known MFI values, again, which are read from your calibration beads. Let's say over time there were some changes in the optics or PMT or something was wearing out. What the device will allow you to do is offset for that and account for that with these known fluorescence values and realign so that you stay consistent through your data. And this results in simplicity of kind of universal instrument setting for your assay. In addition to that, we're offering a 21 CFR Part 11 software. And really this comes down to regulatory environments that require kind of data robustness through the 21 CFR Part 11 process. And so this includes a user management system, an audit trail, and electronic record keeping. And so for the user management side of it, we have a user and role management that's defined by an administrator. This allows for digital signatures to be done in the device and in your data stream. And it allows the administrator also to control rights management. This is LDAP compatible, meaning if your company has already set up rules and rights for your computing systems where you have login names and passwords, that can also be adapted over to the device as well. From an audit trail standpoint, this of course includes secure tracking of all actions. It provides advanced filter function options and functions so that you can locate what was done on a certain day at a certain time or during an acquisition. And of course, it's exportable for Excel and HTML formats. From an electronic record standpoint, all information is saved in one report. This is kind of a forgery-proof PDA digital signature format, and it does allow the report generation to be tracked in the audit trail as well. So that's it for the kind of software updates. To look at service and support overview for the device, we do offer comprehensive service packages. It includes installation, inspection, preventative maintenance, remote support, field-based repairs, upgrades and updates with the software especially, and then instrument qualification, or IQ/OQ. This is being adapted as the instruments release, so we'll have that available in the very near future for this device as well. This includes our support infrastructure globally, so we have inventory management, service training, support, documentation, and service database management as well. For your training purposes, Max Academy offers regular courses for MACSQuant instrument training. They also offer specialized courses for things like our CliniMax Prodigy platform for the clinical T-cell transduction manufacturing, what we call TCT, but also other basic cellular experiments as well. From a on-instrument support basis, we offer a tool called MACSQuant Live Support. And if you've enabled internet access on your device, this will allow you to connect with our MACSQuant support team roughly 24 hours a day, 5 days a week, with offices here in Germany, in the US, and in Asia Pacific. We generally have someone on the computer around the clock to answer calls and requests that come in through this live support feature. It's a pretty simple interface. You simply fill out your information, name, etc. You can ask a question and start a chat with them in real time. Moving on from service and support, we'll go through some performance data really quickly, and then talk about recaps and answer any of the questions that may have come up from you guys during the presentation. So the first data set we're going to show is a 13-color immunophenotyping of human blood. And this in the end really led to 18 cell subset populations to be analyzed on the back end. So you can see the panel on the right side of your screen and what it included. But more interesting will actually be the data on the next page, where we show the gating strategy going from singlets, CD45 positive populations. From there, we're going to monocytes, and then non-monocyte populations will be gated for eosinophils versus neutrophils over here on this right populations. Moving down, we have CD19 B cells versus T cells, and then our B cell subsets. So you have kind of class switch memory B cells, non-switch memory B cells, and then your naive B cells displayed here in the bottom right. Going from the T cell gate, we have CD8 and CD4 subpopulations, and then from there we're able to look at the effector memory, central memory, naive, and effector populations from both of these different CD4 and CD8 subsets. In addition to that, from the inclusion of CD127 and CD25, we're also able to quantify the Tregs that are present in our sample as well. The second panel we'll look at is a 12-color immunophenotyping panel of mouse splenocytes. Again, the panel design and information is displayed here and what was shown on the device. In the next slide, we'll look at the gating strategy. Again, where we start with singlets, look at a scatter plot, gate T cells versus the remaining cell populations. We look at CD4 and CD8 subsets shown here. From the non-T cell population, we'll then look at CD19 versus this MHC class 2. So we have B cells and non-B cells. From the non-B cells, we'll look at dendritic cells in this classical dendritic cell 1 and 2 populations. And then going on from here, we have a gate for looking at neutrophils, and then NK cells here with the NK 1.1 displayed, and then finally myeloid populations with monocytes. Now to revisit the violet side scatter feature of the device, I wanted to show just some comparison data between our MACSQuant Analyzer 10 and our MACSQuant Analyzer 16 for small particle analysis. Now, by all means, I would say that the capabilities of the MACSQuant 10 are still very good. And the data we have here, you have a 100 nanometer going on up to 900 nanometer beads displayed. And if you're looking at the MACSQuant 16 in comparison, I think these arrows are really just to point out the separation that you're getting between these populations in comparison with the other device, which is still able to resolve them, just not quite as well. So from a recap, again, the device is really around bringing simplicity for all of the day-to-day use, setup, acquisition, and maintenance. The automation for a number of different applications, including cell counting, but also the automated transfer of settings for multi-instrument alignment, and then of course expanding the fluorescence capacity, but also the ability to run phyolate side scatter small particle applications. And what this really transfers to, again, is robustness, a host of new features such as the smart gain technology, the ability to do multi-tube processing, IQ/OQ service, 21 CFR software, automation for maintenance, startup, shutdown, cleaning, calibration, sample enrichment, and labeling, and then support with the live support feature with the MACSQuant specialist teams that we have in the field globally, and with our on-site and off-site training and global service offerings.